Alright, so this is the OriginLab uh, user interface, and right here we have different functionalities for you to go through, and you're going to be using this when you're plotting your data and also doing your data analysis. And right here is another section called a Project Explorer. This is kind of like a folder to keep your work organized. For example, I can rename this folder 1 and say that is AB. So things I'll be doing will be saved in this folder called AB. So currently this AB folder has a worksheet called book 1, and this is the worksheet right here. And this worksheet is basically like an Excel worksheet. You can do everything you can do in an Excel using almost the same command like you do in an Excel worksheet. So you can add more column. Currently we have just 2. So to add more column, you just right click and then you add new column, or you can add as much as possible column by coming to column right at the top here and add new column, and we ask you how many columns you want. So you just put the number of columns that you want. For example, I can put like 10 columns. So right now I have these columns, and this is my X. Column A is the X and column B is the Y, and every other columns are Y as well. You can change the identity of any of these columns by just maybe you want your C column to be X instead of being a Y, so just right click and set it as maybe X or even Z if you're plotting like 3-dimensional plot. So you can set this as X. Okay, so next thing I want to show you is how to import your data into this software. So you can drag and drop your data directly, or you can go to File and you select Import, and then you see these several options. So you have several options. You have a single ASCII and multiple ASCII. So the difference is that the single ASCII, you're importing just one ASCII file, and the multiple ASCII, you're importing several ASCII files all at once. And then you also have, that makes your life way easier. You also have the CSV file, you have Excel files, different format, and you have other formats from different instruments. And you also have formats from iGo which is another great software for plotting and data analysis. And you have from Sigma Plot, from Prism, MATLAB, and Origin Program itself. So this makes this software pretty compatible with several instrument, with several software program and other data. So the data I'll be using today is an Excel file, so I just click on Excel and select the data right here. I'm going to add it right here and then click OK. So it comes up with this dialog box. So one pretty thing about Origin is that it gives you so much freedom on how you import your data, which is one of the things that makes it more friendly. It's not a one-way software. So since I'm not doing anything fancy today, I'm just going to click OK. And then it loads up my data. So this is an XRD data, and the x-axis is the true data, and the y-axis is counts. So I'm just going to delete the first row because it's just the information about the columns. All right, so this is my data, and then next thing I want to do is to plot it. So to plot, I'm going to click on Control on my keyboard to select this column, and then select the Y column as well, and then go to plot. So when you want to plot, there are different options to plot. So you can plot as a line, you can plot as symbols, of which you have different kind of symbols. You can plot line as symbol, you can plot a multiple y-axis if you have multiple y-axis data. You can plot panels, like if you want like your graphs and panels. You can also make it in form of like a stack and waterfall, 3D waterfall and things like that. You can also do statistical plot. You can do 3D plot as well, 3D surface plot. You can do area plot and heat map. So several other type of plots that you can do. So you have a lot of things that you can do with the software when it comes to like plotting. So, but today I'm plotting XRD data, and it's a simple line graph. So I just click line. So, and this is my plot. So one thing I want to do is to adjust the scale such that it starts from 0 for the Y, and I'll just double click on that, and this dialog box pops up. So I want it to start from Y. It's currently starting at 500, so I'll just change that to 0. Change this 500 to 0 and click apply. You see it change. And for the x-axis, I want this to start from 2.5 to 40. And I click apply and it just makes the changes. Another thing you can do is that you can make a lot of changes, like in terms of like the tick labels. You can change the tick label, in terms of the font style and things like that. You can change the title of the graph. You can add a title if you want to. You can change the line and ticks in terms of the length and the thickness. You can also put grids. You can put special ticks and breaks. So you can do anything that you want, basically. So you just click OK. I'm satisfied with what I have right here. And we have this box here for counts. So this is the legend. So this is telling you that this data is this black line. So it's currently counts. So for example, if you have multiple data plots, multiple data that you put on the same graph, you can use this legend to like distinguish them. So for instance, I can change this plot to red, and that should change the legend as well. So it should change to red. So I can, for example, call this compound 1. Okay. And then I can do like a mirror axis as well. I like to have that because it makes my plot looks more professional. So I'm just going to delete this. I don't need this ticks as well. I just want the box for my data. So I double click on this and then I'm going to turn off the line and the ticks, turn off the ticks rather. So I go to the major tick, you select none, go to the minor tick and then you select none as well. You do the same thing for the right axis. You just change this to none and you click apply or OK and you have this. So another nice thing about Origin is that you can zoom in on the region of interest that you want to look or have more information about without having to like go through the process of adjusting your scale to do that. So all you just have to do is you come to this icon for zoom, you select it, and then you drag over that area of interest. For example, if I want to look at 5 to 10, I can easily look at it. And then if I, for example, want to read a data point, so I can select this. If I want to know what the corresponding value of X and Y are at this point, so I just click this and I can see the values right here. So we'll just zoom back and this is my data back. So another thing is that if you want to import this plot, you can just go directly to File and export it. You open your dialog and it comes up with this box dialog box as well. So it's asking you what type of format you want to export your plot. So you can export in different kind of file formats. You can export as PDF, you can export as JPEG, PNG, TIF, whatsoever one you select. And then you also can change the dimension of the plot right here by adjusting the height and the width of it. You can change the pixel, you can change the DP high resolution if you want to have very high resolution plot. So you do that and then you click OK after you've put the file name and then you have your graph. So it will look very high resolution. Okay. Can see. So if you're in a hurry and you just want to make a plot, maybe you're interacting with your group and trying to decide on, how to finalize the details of this plot, you can also send this directly to a PowerPoint and asking you questions as well. Just click OK, go straight to PowerPoint and you have it in the PowerPoint. So you can save this as a PowerPoint and send it to somebody else within the group. And if that person has Origin, he or she will be able to open it on their computer by double clicking as well. And then it's going to open up the data in Origin. So this is it in Origin after the person double click, and the person can make several changes to the data as well, whatsoever they want to do, and they can keep collaboration that way. You don't have to go back as the person that makes the plot each time to like make the changes. It can easily be made by somebody else. And then you can also get access to the raw data that made up this plot by just right clicking and selecting plot details. And then there'll be a workbook here. You click on the workbook and then you have the raw data. So I find this very powerful because I can easily, if I want to change like the scale, like if I want to change the or convert from one unit to the other, I can easily do that without requesting for the raw data all the time. So I find this pretty interesting and nice. So I'm just gonna close that. Okay. No. And then I'll close the PowerPoint as well. So I've shown you how to import your data into Origin and also how to export the plot out in different formats and also to PowerPoint quickly. So you can rename this graph as well if you like, just to keep track of things. Next thing is that I want to show you how to deconvolute data. So to do that, we just create another folder, and I'm going to call this deconvolution. Okay, and I'll create a worksheet in this folder. So everything that we did previously, it's in this AB folder, like you can see them. And this new folder will be where I'll be showing you the deconvolution. So to do that, I'm just going to copy the data and paste it in this new worksheet. So paste. So I have the data pasted here. So this is a UVV spectrum, and the x-axis is currently in wave number, and the y-axis is correctly in extinction. Is the extinction coefficient. Okay. So I'll create another y-axis, add new column, or I just add new column. The reason is because I want to convert this wave number to nanometers, which will be the wavelength. And the good thing is that I can do this calculation in Origin itself. So to do that, I just right click and then select a set column value. So one good thing is that you can do a lot of calculation in Origin, just like you can do in Excel. And you have the formula. You can load a formula from the already existing library. You can create your own library and load your formula from there. And also you can use different functions as well. So there are different functions: string, mathematical functions, engineering function, complex function, even from or use Origin C, which is kind of like a programming language. So statistical functions as well. You can do a lot of things, but I'll be doing very simple thing today, which is to convert from reciprocal wave number to nanometer. So the conversion formula will be 10 million divided by column A, because column A is the one in wave number. So I just click OK, and then it gives me the result in here. To see all these values, you just need to like drag this column, and you can see the values in nanometers. So you can put the unit in nanometers, and you can put the unit here as well. This is per centimeter, per molar per centimeter, and this is in reciprocal wave number. So this will be my new x-axis. So to do that, I'll first move this to the left, and then I'm going to set this as x-axis. Okay, so now this column is correlated with this. So what I'm going to do next is now to plot. So I select and make a plot. It's going to be a line plot as well, and here's my plot. So I'll just use the zoom in to zoom in on the region of interest. Okay, I can adjust the intervals to 20. Okay, and then I can make the box plot as well. I'll delete this, and I can actually go back to these plots that I made previously and copy the format. So I just copy format. I'm going to copy all style format and go to the new plot that I'm making and then paste the format. Okay, So Origin is very smart to that extent. Actually, you can also save this theme if you really like it. For example, I can make this like a width of 2 to make it clearer. So if you really like this, you can save this theme, this format as a theme, and just save this, give some description, give it a name, and then you just save it. And you can always load it up whenever you're doing similar plot, just to make sure that you have some consistency with your plot. So now I have the plot, and I want to show you how to perform some deconvolution. So to deconvolute, you can actually select the area of interest by using this tool called selection on active plot. So if you click it, you're going to select the area, which to me would be this region. So that is the region of interest. So you can see clearly. I'll change this to black. So it will be these regions within the red vertical lines. So that will be the area that I will be performing some analysis on. So deconvolution simply means that you have two peaks that are overlapping and you want to resolve them. So right here, I can see this peak clearly. I see the maxima. I can see this maxima clearly, but I don't know where the maxima for this is. So in order for me to have an information about where the maxima is, I have to be able to resolve these two peaks. So to do that, I will go to analysis and go to peak and baseline, and then go to peak analyzer, and then go to open dialog. So this is asking me about the goal of this process. So the goal to me is to perform peak deconvolution, which will be fit peaks here. So you select fit peaks, and then you go to next. And then it's asking you about the baseline. So the current baseline is constant. That's the option. And you can look at it. It pretty looks good. But if it doesn't look good, you can define your own baseline by using the user defined. And then you have all these dots which you can move around maybe to the bottom to select where you want your baseline to go through. But the constant option looks pretty good to me, so I'm just going to go with that. So I just click next, and then I'll click next. And then the next thing is to find the peaks. So the software has the auto find, which it's already checked. So if you click that, it's going to look for the peaks. So it thinks that there's a peak here, there's a peak here, which they are correct positions for the peak. But there's also a peak here, but it's not sensing that. So I know it's there, but it's not seeing it, so I can help it to see it. So I'll just uncheck the enable auto find and select add. So then I'll double click somewhere around here and then click done. So now I have it selected. Okay, I think there's a peak around this region. So the next thing will be for me to click next, and then I'll be able to like fit the peak and find the maxima for that peak. So now it shows this and comes up with this dialog box again. So now you can see there's a fit control here. So for example, if you want to do some constraints, you can increase the number of iteration or decrease it. You can set your tolerance for the fit. You can enable some constraint and put the constraint condition here. You can set like boundary parameters. You can put some parameters here that you want to keep constant or vary and things like that. Just a way to kind of fit your data. So, but I'm not doing anything fancy, so I'm just gonna click OK, and I will just go through here as well. You can see you can set the type of weighting you want, like instrumental, statistical, direct weighting. You can select if you want residuals to be shown. You can modify the kind of results that you want in the output of your fit. But I'm not going to do anything really special, so I just click fit, and then it fits it, and then I click finish. So now it's asking me if I want to see the report sheet for the fit, so I'll click OK. So it basically will show me the statistical result for the fit, like the standard error, the number of point, the degree of freedom, the reduced chi-square, adjusted R-square, if the fit is successful and things like that. And then it gives you actually the fit here and the residual factors independent variables. So let's go to the actual fit, and I'm going to increase the magnification of this for you to see it clearly. All right, so this is the actual fit. So you can see right here, we have the black line, which is our data, and then there's the faint red line here. I'm going to change that to 2 for you to see it. Actually, I just change everything to 2. No, okay, let's just keep it like this. So the black line is your data. The red line is the cumulative fit, which is a addition of the independent fit, which are the ones in green right here. So the closer the red line to the black line, the better is your fit. So you want the two lines, the red and the black, to be identical, and that is when your fit is good. Another indication of your fit is the goodness of your fit is the adjusted R-square. So the closer this value is to 1, the better is your fit. So currently we have it at 0.999. So this is a very good fit. And the result of the fit is right here. So it's telling us the center of gravity. So we have a peak at 203, which is this peak right here. And then we have another one at 237, which is this one right here. Pretty easy to identify. But the one of interest is the one right here. So what's the maximum for that? So that is 255 nanometers, right? And also it gives you the peak area for each of these peaks. So this is very important whenever you're working with things like quantization, like an XRD, where you want to get the peak area of a particular peak in order to quantify the amount of the forms or maybe the impurity that is responsible for that peak present in a particular matrix. So it's very good for building a quantization model. So due to time constraints, I wouldn't be able to show you so much about this program, but basically I'll just run you through some other things you can do. You can also use the software for like a statistical analysis, like descriptive statistical analysis. So for example, you can do different kind of descriptive statistical analysis, like statistical normal test, distribution fit, and things like that, Grubbs test, Dixon-Q test. You can do hypothesis testing, different types. You can do ANOVA. You can do parametric and non-parametric testing. You can do like survivor analysis. We can do multivariate analysis, like principal component analysis, partial least square. You can do power and sample size, and also you can also do some mathematics analysis as well, like interpolation, 3D extrapolation, differentiation. You can also do like signal processing, like smoothing your signal. If you have data with a huge amount of noise and you want to denoise it, you can use this function, like filter out the noise from the actual data. You can do like a wavelets construction and decomposition. You can do convolution, and you can do like coherence and correlation analysis as well. So very useful. Also, you can have apps. So there are some apps that are already built into the software, like ODE solver to solve differential equations, Agilent mass spec reader, polynomial surface fits. Also, you can also create your own app and interface it with this software, or you can even create it within the software. Yep. And also you can interface this with other software like MATLAB, R, which is a programming software. You can also interface it with Python. You can interface it with a mathematical link. For example, if you open up the Python link, you can do some Python scripting here as well. So it's pretty useful. It's kind of like a point and execute software, kind of like a one-stop shop for several things for data analysis and interpretation. And so it's a pretty useful software. So if you can use Excel, you can use Microsoft Word, you can use PowerPoint, you can basically use this software. So if you want to do data analysis and you don't want to do like programming, like in MATLAB, then this is the software for you.